can do video on design of a trapezoidal footing. In this video, you will learn to define the properties of the trapezoidal footing in the SAFE software. You have already been explained the problem statement and the initial calculations. Now, you will proceed with the design in the software. Open the SAFE software. Go to File and select New Model. Change the design code and check the units. In the design preferences, change the clear cover at top and bottom to 50 each. And change the preferred bar size to 20. Click on OK. Now there is no template for trapezoidal footing. In this video, you will learn how to draw any footing by yourself manually, without using templates. To draw the trapezoid, you will take the help of grid lines. The grid is a coordinate system of construction lines that form a framework to assist you in drawing the model. Consider it like a graph paper, on which it is easy for you to draw any shape, with the correct dimensions. Select the grid-only option under the templates. Now, the maximum length of the trapezoid, in the X direction is 4, and in Y direction it is 3. But there is a spacing value of 1.25 meters of the column from the edge, which means the least count of the grid spacings should be 0.25 meters. The number of grid lines, having 0.25 meters spacing between them, should be 5 for a 1 meter length, with one grid line each at 0.25 meters, half a meter, 0.75 meters, 1 meter. You will understand it more clearly when you draw the trapezoid on the grid. Thus, to draw a 3 meters length in a grid system, you need 4 times 3 plus 1, equal to 13 lines. Similarly, for 4 meters, you need 4 times 4 plus 1, equal to 17 lines. So enter the number of grid lines as 17 in the X direction and 13 in the Y direction. Then enter the spacing values of 0.25 meters in both. The corresponding grid has been formed, on which you will draw the trapezoid. Before drawing the trapezoid, you will define the properties, using which you will place the footing area. Go to Define, and click on Materials. Add the M30 concrete, and the HYSD 415 rebar. After the materials are defined, you will define the footing and the column with these materials. Go to Define, and select Slab Properties. Unlike the previous videos, the footing or stiff is not mentioned here. This is because you are not using any template, but will be drawing on your own. Click on Add New Property. Enter a name to identify the property of the footing. Change the slab material to M30. For the thickness, you will start with a minimal thickness of 300 mm, and check the design. So enter the thickness value of 300. Then click on OK. The footing property has been defined. Now, as the stiff is not listed here by default, you can define the column property separately. Click on OK to exit the Slab Properties dialog box. Go to Define, and click on Column Properties. You will be defining two separate columns, Column 1 and Column 2, having two different dimensions. Click on Add New Property. For Column 1, change the material to M30 and the dimensions to 350 by 350, as illustrated. Click on OK, and the Column 1 is defined. Again, select Add New Property to add Column 2. Change the material to M30, and the dimensions to 550 by 550. Click on OK. Both the Column 1 and Column 2 have been defined. Click on OK to exit the Column Properties dialog box. You have defined the footing and the columns. You are left to define the soil and the loads. Go to Define, and click on Soil Subgrade Properties. You can either add a new property, or modify the existing one. Click on the already present soil property, and select Modify/Show Property. The calculated subgrade modulus is 2 times 10 to the power 4. Change the subgrade modulus value to 2e plus 4, and click on OK. The soil property has been defined. Click on OK to exit. Next, check for the load patterns and load cases as shown. Then select the Load Combinations option in the Define menu. Add the two load combinations, one for the ultimate load, and the other for the service load. Once the two load combinations are added, click on OK to exit. You have defined all the required properties for the footing model. In the next video, you will learn to draw the elements of the footing and assign the properties. Thanks for watching.